Hey guys, I was just in here working on my capacitance in my 5-gallon buckets. On this one here I got 14 bottles. They're all tied together. We're looking at almost 14 nanofarads. It's actually 13.85. This capacitor here, I got another 9, I believe. 2, 4, 6, 8, 9. I don't have these connected, but just that batch there. And what I'm doing right now is just goofing off, but I'm mixing top loads to the capacitance and bouncing back and forth and seeing what different metals are, what they're doing size-wise, space-wise, volume. I'm changing the positioning of the primary to match the capacitance. The more I put on the top load, a bigger top load, the farther away from the center. This is my hot, this is my ground at the very end here. The bottom of the secondary goes to ground. And I'm running off a 7500. I'm using only half of my NST. And this is my new engine here that I'm working on. This is 2 Mach capacitors in series. Putting out, running 110. So that means there's 60 volts going on each one. They're putting out 4,000 volts, and I am working on right now on bringing better power into my workshop here so I can run 220 to these, and then I will have 120 going in each one, and that'll step up not only my current, my amperage, and I'm also putting a doubler inside here, and that'll double my volts. So I'll be at 2, 4, I'll be at 8,000 volts with, I figure with the capacitance that I'm going to be adding to my system, I should be, well, the capacitance is 6 of these microwave capacitors. These are 2300 volt, 0.91 microfarads. Okay, so I'll be putting 2 of these in series and 4 of those in parallel, and that will give me about 2.7 amps. So having that much current coming out of these moths is going to be freaking insane. And then I'll match the top load in the primary to the secondary and put this bitch in resonance. And I like to get some Abrams Labs and some Tesla Explorers arcs coming out on many of Abrams. Actually, Terry too, man. Terry's got some great big thrust coming out. But yeah, this is just all learning. And, you know, if you look back in some of your videos, you can see all you guys are, you can see how you learned and what you did a year ago, and progressively how things change. And that's where I'm at right now. It's just about finding the capacitance and matching up the values. And when you build these coils, you know, they have a built-in resonance about them, and you want to know what you're getting into before you build them. So if you guys want to, anybody out there that doesn't know things about the Tesla coil, there's a software out there. It's free. It's called Java. It's a calculator. You can plug in all your values and it will give you accurate, I mean 100% accurate on your capacitance going in your primary. It'll give you your resonance of your secondary and your primary, and it will give you so many other things, you know, how many turns diameter, inside, outside, low voltage, high voltage, ground from the bottom of the primary to actually the ground matters. So there's a lot going on. But I'll kick this on. I wanted you to know I got the steel. This is my Ed Scallon. I put a coil inside here, and I get the strongest magnet, like a lifting magnet. So this is all iron with a solid bottom. Had this all welded. 1.5 inch square stock on the inside, and I just stuck this. It goes off and arcs come off of it. I'm pretty impressed with iron because everybody's using just conductors, and this is just an experiment. And I'm impressed with 13.85 nanofarads. Backed up 1, 2, 3, 4, 5, 6, 7 spots on my primary. And I got my 24 gauge 520 turns. Resonant frequency on this secondary is 689 kilohertz, and where this primary is backed up is matching the resonancy of the secondary. So let's go ahead and kick the sumbitch on. One thing I want you to notice, I'm going to focus, look above the B. The minute I just turn this thing on, you're going to see little sparks go in between the one street sign and the other is a little air gap, and that sign is not connected to anything. So literally you can see a little spark going in between over there. It's pretty interesting. Let me kick this on. I got my Variac. I got it down real low right now. In fact, I'll just turn it off and we'll build up the process. All right, guys, very loud. Won't be able to talk, but put your eyes on this, okay? There we go. So let's watch right there. You see that? Look above the B. You see that spark? Down here. Let's spark it. Spark gap. Get the spark gap real tight. The way that's going to go anyway. But you see that spark up there? That's just picking it up from the air. Crazy. Alright, so let's go ahead and turn it up. Oh, look at that thing glow over there. Alright. So you can see the blue light up there. And this is with the spark gap basically closed. Okay, now we'll go ahead and open up the spark gap a little bit. Light bulb in the back lighting up. All right, guys. Well, leave some questions. Like your comments. Thanks for following, guys. Iron top load. Bye.